Hello. So I built an Ethercat project this past few days, and I would like to share it to you. Forgive the wirings, and later on I'll go in much more detail on each one. But as an overview, so this is the Raspberry Pi. It acts as the master. I'm using open source libraries, so there's something called a simple open Ethercat master, and I compiled it in here and just write an application on top of it. And as you can imagine, there's an Ethernet cable right here, which where the data frame travels, and then there's this is an Ethercat slave controller. Yeah, so as a slave controller, this is the one where it's responsible for processing the data frames on the fly. It's supposed to pass the data frame out of this port, but at the moment, we have a hardware limitation. I only own one of this and one of the motors. So ideally, for an Ethercat project, you would have multiple slaves. But at the moment, we only have one. And also, worth noting that the master is ready to actually talk to multiple nodes. The firmware is ready right here. Yeah. So more about this. It has an SPI right here, and that's where the ESP32 interfaces with it. It has an interrupt pin where it asserts when it receives a data frame so interrupt. So the interrupt asserts, and then the ESP32, which is the slave, it's running Zephyr RTOS inside, and also simple open Ethercat slave. So it's from the same company, the one that I found online. So yeah, so as soon as it receives, an interrupt from this, reads via API, via SPI, and then right here it's connected to the stepper driver, which gets powered through 12 volts through the wire right here, and then motor, which is powered through the stepper driver. Yeah, so I'll go much more in detail on each one of them later on. Yeah, so before, when I started out, when I started out building the project, I was doing a little bit of research about Ethercat, and then figured there's actually multiple communication modes in Ethercat. One being the most popular is COE. I think it's called CAN Open over Ethercat. And there's other types as well, but what I did was since I was using open source libraries for master and slave, I checked which type is already supported. So I chose COE. Yeah, so that's what I'm using. Yeah, so let's talk about the master. Yeah, so let's talk about the master real quick. So as I said earlier, I'm using simple open Ethercat master library, and I just wrote a wrapper on top of it, an application that basically calls the API from the library to do what I wanted to do with the motor, or to communicate with the slave controller. So to show you, basically I have not this one, not this one. Yeah, so this one. So yeah, so you can see that there's this functions right here. Gives me the slaves found to give you a short demo of how this works. Basically, just scan right here, and it's gonna give you this, and you can also read the registers from the slave controller right here. Oh yeah, and one thing that I would like to talk about, which is one thing that I found interesting when I was building the master side, was the AL control and status. So basically, there's four states when you're, to work on this slave controller. There's init, there's pre-op, and there's safe op, and there's also op. So the names are self-explanatory, but give you a little bit of idea how each state works. So for the slave controllers, as soon as you powered it, as soon as you power it on, it's gonna set itself to init status. So what that gives you is you can now read and write to its own registers. So to move from one step to another, so from moving from init to pre-op, you're gonna have to write to the registers. I think it's the control register. Remember it on top of my head, but what you're gonna have to do is you're gonna have to set up the SDOs. So I think it's mailboxes. Remember I said earlier I'm using COE, can open over Ethercat, so that gives you PDOs and SDOs. So moving to the next stage, which is pre-op, you have to enable the SDOs, so now you can actually configure the device the way that you want to do. So PDOs are for like actions. So at this point, you still cannot do actions, still cannot do commands. So for safe op, what you still haven't opened the PDO. So this time you're gonna have to configure the mapping of the process data. You also have to configure the sync managers, FMMUs, and then the slave is gonna give you basically a return if you succeeded or not. And then if you did, you're gonna be at safe op, and at this point you're done configuring everything. And what's gonna happen is, you're still gonna write the same control register, and as frames are gonna keep arriving because PDOs gives you the cycle basically, and then it's just gonna start acting on it. That's pretty much it, and then you're at op. Yeah, so let's now talk about the slave controller. So I'm actually using this. Let me make my thing. Yeah, so you can read here. It's an Ethercat slave controller. They're actually a company in Taiwan. Yeah, that's pretty cool. And yeah, so how I used it is basically I have SPI pins here, and there's also interrupt pin, and also sync 0 and sync 1. So let me first talk about the interrupt. So basically what happens is, obviously I'm connected to the slave, which is the ESP32. So what happens is the pins, the chip pulls low, and the ESP32 basically, detects this and then reads over SPI. And the precise thing here is that the ESC never actually sends anything to the ESP32. It puts its data to its own memory, and then the ESP32 comes and fetches it. Just normal SPI communication. Yeah, and then that's pretty cool. Yeah, so there's also another pin right here, which is the sync 0 and sync 1. I'm using the sync 0 right now, and this one's pretty interesting. So basically, there's like 3 types of synchronous here. One is free run, where you don't really care, just the slave run in its own timer. I guess if your use case doesn't really need synchronous between different slaves, then you can run it free running. There's sync manager synchronous. I think it's called SM sync, and there's also distributed clock, which is what I'm using. So basically, while it's running, there's a cycle that keeps everything on track. So the data frame goes on a chain, right? And what it does is it records the delay between each slave. So the master can now know how much the timer within the slave and within the slave to the slave tree, how much it delays between this. So when it sends a command, you can now actually do some calculation within its own self, and then have the slaves act synchronously. Because if you know the delays between each slaves, you can now actually just calculate this and then make a command that says run at this certain time, and then this certain time for this certain time, because you now know the delays between each of them. As opposed to SM synchronous, basically to my understanding, it acts as soon as it receives the data. So not no smart calculation as compared to the distributed clock synchronous. Yeah, so let's talk about the slave now. So the ESP32 acts as a slave here. It runs Zephyr RTOS and also the SOS, which is this. It's the other end of the SOM, which is the master, and then yes, it's simple open source Ethercat slave basically. Yeah, so remember when I explained what the master writes to the ESC, and then you move from different state, and this is pretty much involved with it as well. So if you remember, there's a control register right here. So SOS is the one that's on the other end that's gonna basically kind of like confirm. So if the master asks to go op, and SOS can either reply yes if it could do it or not. So depends on the command that you send. But in our case, if we ask it to move, it's gonna move. So that's the part for the library, and for the other things, just simple embedded work, because you just talk to the stepper driver right here. You send the step and direction, and then you pulse the motor, and then it's gonna move. And that's pretty much it. I don't really want to make it this video too long, but guess we could talk about more in person.